The Big Bang did not bang. There was no sound, no explosion as we understand it, no flash of light piercing the darkness, no moment when nothing became something. The origin of everything we know was, in truth, utterly silent. The beginning of time itself unfolded in perfect, absolute silence, in a void where sound could not exist because nothing existed to carry it. This is our first great cosmic misunderstanding. That creation began with noise, with chaos, with some tremendous, perceivable event. But how can you perceive what happens when perception itself is born? How can you witness the birth of witnessing? You've been told a story since childhood, a creation myth dressed in scientific language. But what if the truth is far stranger than the comfortable narratives we've accepted? Imagine rewinding the universe, every galaxy, every star, every planet, every atom, back to its supposed beginning. What would you actually see? Not an explosion outward from a single point, as you've been led to believe. The universe didn't expand into anything. Space itself was born, stretched, and continues to stretch. There was no outside for it to expand into. There still isn't. When cosmologists speak of the universe expanding, they aren't describing it growing into some larger container. They're describing the very fabric of reality stretching itself, creating more of itself from itself. The cosmos isn't expanding like an explosion. It's expanding like a thought, expanding into consciousness. Does this distinction trouble you? It should, because it suggests something our minds struggle to grasp, that the universe may be fundamentally different from how we've imagined it. Right now, billions of light years away, galaxies are rushing away from us, faster than the speed of light, not moving through space faster than light. That would violate physics as we understand it. But riding the expansion of space itself, which bears no such speed limit. These galaxies have already disappeared beyond what we call the cosmic horizon, forever unreachable, forever unseeable, yet still part of our universe. Reality extends far beyond what is observable, beyond what is knowable. The universe you can see is merely a fraction of what exists. The cosmos keeps secrets, even from those who study it most intimately. Light from the furthest observable galaxies has traveled for over 13 billion years to reach your eyes. When that light began its journey, Earth didn't exist. Our sun didn't exist. The very elements that compose your body were still being forged in the hearts of ancient stars. You are looking at objects not as they are now, but as they were before the Earth was born, and the light from some objects will never reach us. Not because of distance alone, but because the universe's expansion is accelerating, dragging galaxies away from each other at ever-increasing speeds. The cosmos is not just vast, it's actively becoming more unknowable with each passing moment. Perhaps most troubling is the dark confession cosmologists rarely emphasize. 95% of the universe appears to be composed of substances we cannot see, cannot touch, or directly measure. Dark matter and dark energy, placeholder names for phenomena we don't understand, make up the overwhelming majority of existence. We've built our understanding on the 5% we can observe, while the true nature of reality remains hidden in plain sight, invisible, yet exerting its influence on everything. What kind of science is built on such a foundation? What kind of understanding can we claim when nearly everything remains beyond our grasp. You might wonder how we arrived at these conclusions. These theories about beginnings and expansions and invisible forces. We've constructed elaborate mathematics, launched sophisticated telescopes, and collected terabytes of data. But at the foundation of it all lies an assumption so fundamental that we rarely question it: that the laws of physics governing the atom in your fingertip apply equally to the furthest reaches of the cosmos and the earliest moments of time. What if this assumption, this extrapolation across 93 billion light-years of space and 13.8 billion years of time, is our most profound mistake? Consider the implications if the universe doesn't play by consistent rules. What if the constants we've measured, the strength of gravity, the speed of light, the behavior of quantum particles, aren't constant at all? What if they shift subtly across vast distances or long timescales? What if reality itself has evolved, its fundamental nature changing as it aged? Our certainties would crumble, our equations would fail, our understanding would be revealed as nothing more than a local approximation, like mistaking the rules of your neighborhood for the laws of an entire planet. The universe is not just stranger than we imagine, it's stranger than we can imagine. Our brains evolved on a small rocky planet, adapted to understand medium-sized objects moving at medium speeds. We developed intuitions about cause and effect, about objects and boundaries, about time flowing smoothly forward. Yet modern physics has systematically dismantled each of these intuitions. Quantum mechanics reveals particles that exist as probabilities until observed, that can be entangled across any distance, that can tunnel through impenetrable barriers. Relativity shows us that time and space are malleable, that simultaneity is an illusion, that the passage of time depends on where you are and how you're moving. Our most sophisticated theories don't just challenge our intuitions, they obliterate them. And what of time itself? You experience it as an arrow, always moving forward, never pausing, never reversing. Yet this most fundamental aspect of existence, this river we're all swept along by, remains perhaps the greatest mystery in physics. Some equations suggest time is an illusion, that past, present, and future all exist simultaneously in a vast block universe where change itself is just a perspective. Others hint that time might be quantized, coming in discrete units like frames of a film rather than flowing continuously. Still, others propose that time emerged from quantum entanglement, a secondary property rather than a fundamental dimension. What happens to your understanding of reality if time itself isn't what you thought? Look up at the night sky. The darkness you see is not empty. It's filled with forms of energy and matter. Your eyes cannot detect, your instruments cannot measure, and your mathematics can only approximate. The stars and galaxies, those rare islands of visible matter, are like scattered campfires in an unimaginably vast and darkened landscape. And between those fires flows something we call dark energy, a mysterious pressure that permeates all of space, pushing galaxies apart with increasing speed. We didn't predict its existence. We discovered it by accident and have spent decades trying to explain it. Its nature remains one of the greatest unsolved mysteries in modern science, yet it constitutes roughly 68% of everything that exists. Alongside dark energy lurks dark matter, another 27% of the universe that refuses to interact with light or any other form of electromagnetic radiation. We cannot see it. We cannot touch it. We know it exists only through its gravitational effects. The way it bends light from distant galaxies, the way it influences the rotation of spiral galaxies like our own Milky Way. Without dark matter, galaxies would tear themselves apart. They spin too fast for visible matter alone to hold them together. This invisible substance forms vast halos around galaxies, extends in filaments between them, and shapes the largest structures in the cosmos. Yet, despite decades of searching, we've never directly detected a single particle of dark matter. We're surrounded by something utterly alien, utterly unknown. Perhaps most unsettling is the phenomenon of quantum entanglement, what Einstein famously called spooky action at a distance. When particles become entangled, the properties of one instantly influence the other, regardless of the distance separating them. Change the spin of one particle, and its entangled partner reacts immediately. Not at the speed of light, not after some delay, but instantly, as if space itself doesn't exist between them. This phenomenon has been tested repeatedly, confirming that either information can travel faster than light, violating relativity, or reality is non-local, violating our fundamental understanding of cause and effect. Both possibilities shake the foundations of physics. You exist in a universe where the vast majority of matter and energy remains invisible and unknown, where time might be an illusion, where particles can influence each other instantaneously across any distance, where space itself is stretching like an infinite fabric, carrying galaxies beyond our cosmic horizon. And all of this emerged from a beginning we cannot observe, cannot model accurately, and cannot truly comprehend. The story you've been told of a Big Bang, of an expanding universe, of galaxies and stars and planets forming over billions of years, is at best an approximation, a simplified narrative that captures some aspects of a reality too complex, too alien for human minds to fully grasp. What if the universe isn't expanding at all? What if instead, all matter is simultaneously contracting? Mathematically, the two descriptions are equivalent. There's no experiment we could perform to distinguish between an expanding universe and a universe where all matter, including our measuring devices, is shrinking at a precise rate. Our perception would be identical in both scenarios. This equivalence reveals something profound about cosmology, that our models describe relationships rather than absolute truths, that multiple contradictory narratives can be equally valid descriptions of reality. Even more troubling is the horizon problem, the observation that the cosmic microwave background radiation, the afterglow of the Big Bang, has nearly the same temperature in all directions, despite originating from regions of space that could never have communicated with each other. It's as if opposite sides of the observable universe somehow agreed on a temperature without ever having been in contact. Cosmologists proposed cosmic inflation to solve this problem, a period of exponential expansion in the universe's first fraction of a second. But the theory requires introducing entirely new physics and fields that we've never directly observed. We've built elaborate theoretical architectures on foundations we cannot test. And what of the singularity itself, that supposed point of infinite density and temperature where space and time began? Our mathematics breaks down completely when trying to describe it. General relativity, our best theory of gravity, predicts its own failure at the moment of creation. Quantum mechanics, our best theory of the subatomic realm, cannot reconcile with gravity at these scales. The beginning of everything lies beyond our theories, beyond our mathematics, beyond our ability to model or simulate. We speak with confidence about the first few seconds after the Big Bang. But we cannot describe the beginning itself. It remains, in a very real sense, miraculous, a point where science reaches its limits and can proceed no further. You might wonder about what came before. What existed prior to the Big Bang? What caused it? What set our universe in motion? But these questions may be fundamentally meaningless. Time itself may have begun with our universe. Asking what came before time is like asking what lies north of the North Pole. The question contains an implicit assumption that makes it unanswerable. Stephen Hawking compared it to asking, what's south of the South Pole? There's no south beyond that point. The concept loses meaning. Similarly, there may be no before the beginning of time. Or perhaps our universe is just one bubble in a vast multiverse, one possibility among an infinite landscape of possibilities, each with its own physical laws, its own constants, its own dimensions and particles and forces. Perhaps what we call the Big Bang was merely the birth of our particular cosmos, one transitional event in an eternal process that has always been occurring and will always continue. Perhaps reality is vastly larger, vastly older, and vastly stranger than the observable universe suggests. Perhaps what lies beyond our cosmic horizon isn't just more of the same. More galaxies, more stars, more planets, but something fundamentally different, operating according to physics we cannot imagine. What if the constants that make life possible in our universe, the strength of the forces, the mass of fundamental particles, the dimensions of space, were different? In most scenarios, stars wouldn't form, chemistry wouldn't work, and complexity would be impossible. Our existence balances on a knife edge of cosmic fine-tuning. Change the strength of the electromagnetic force by just 4%, and molecules cannot form. Alter the strength of the strong nuclear force by just 1%, and stars cannot produce the heavier elements essential for life. Is this remarkable coincidence just that? A coincidence? Or does it hint at something deeper? A multiverse, where all possibilities play out, and we necessarily find ourselves in one of the rare bubbles where consciousness can emerge? Or perhaps something more deliberate, more intentional? The concept of a multiverse, an infinite collection of universes, each with different properties, emerged not from wild speculation, but from our most sophisticated theories. Many interpretations of quantum mechanics suggest that every possible outcome of every quantum event occurs in some branch of reality, creating an ever-multiplying tree of universes. Inflation theory suggests that the process that expanded our early universe continues eternally in other regions, spawning new cosmic bubbles with potentially different physics. String theory suggests a vast landscape of possible vacuum states, perhaps 10⁵ different configurations of physical laws. If these theories are correct, our universe is one leaf on a tree of possibilities so vast that the mind cannot properly conceive it. Look again at the night sky. The darkness between the stars isn't empty. It's filled with light your eyes cannot see, matter your body cannot detect, and energies your instruments struggle to measure. Cosmic rays from distant supernovae pass through your body by the thousands, every second. Neutrinos, ghostly particles that barely interact with normal matter, stream through the Earth as if it were not there. Gravitational waves, ripples in the fabric of space-time itself, stretch and compress you by subatomic amounts as they pass, too subtle for you to notice. You are immersed in a sea of cosmic influences that your senses never evolved to perceive. And what of the light you can see? Those distant stars, those ancient galaxies. The photons reaching your retina have traveled for years, decades, millennia, millions, or even billions of years. Perfect messengers carrying information across the vastness of space and time. Yet they tell an incomplete story. By the time their light reaches us, those stars may have died. Those galaxies may have transformed. We see the cosmos not as it is, but as it was. A museum of light, a historical archive rather than a current snapshot. The universe you perceive is a ghost of the past. Consider the simple fact that light has a finite speed, that information cannot travel instantaneously across the cosmos. This fundamental limit means that each observer has their own cosmic horizon, their own sphere of possible knowledge. Events beyond that horizon cannot be known, cannot be observed, cannot be influenced. Distant parts of the universe are not just far away. They are, in a very real sense, causally disconnected from us. What happens there cannot affect us. What happens here cannot affect them. The universe fragments into islands of causality, regions that will never communicate, never interact, never know of each other's existence. You might ask why? Why is the universe so vast if most of it remains forever beyond our reach? Why so much complexity if most of it remains forever unobservable? Why such rich structure at scales both far larger and far smaller than human perception? The cosmos wasn't built for us. It wasn't designed for our observation, our understanding, our comfort. We emerged within it, a recent development, a local phenomenon, possibly one of many throughout the vastness of space and time. The universe doesn't owe us comprehensibility. Its strangeness isn't a flaw, it's a feature, a reflection of reality's depth beyond our evolutionary adaptations. The cosmic microwave background, that faint afterglow of the Big Bang, represents the oldest light in the universe, released when the cosmos was just 380,000 years old. It comes to us from every direction, a perfect fossil of the early universe. But it also represents a wall, a boundary beyond which we cannot see using electromagnetic radiation. The early universe before this time was opaque, a hot, dense plasma that scattered light rather than transmitting it. No telescope, no matter how powerful, can peer beyond this cosmic wall using light. The universe's earliest moments remain hidden from direct observation, accessible only through theory, through inference, through mathematical extrapolation. What if our universe isn't the fundamental level of reality? What if it's a simulation, a projection, a shadow of some deeper structure? This isn't mere philosophical speculation. Some of our most sophisticated theories suggest that reality might be holographic, that the three-dimensional universe we experience might be encoded on a two-dimensional surface at the boundary of space, much as a hologram encodes 3D information on a 2D surface. The mathematics of black holes, string theory, and quantum gravity all hint at this possibility. Reality may be radically different from our perception of it, not just in details, but in its fundamental nature. And what of consciousness itself, that remarkable phenomenon through which the universe has developed the capacity to observe itself, to study itself, to question its own nature? How does awareness emerge from arrangements of matter and energy? How does the objective world of particles and fields give rise to the subjective experience of being? This question, the hard problem of consciousness, remains one of the deepest mysteries in science, a bridge between physics and philosophy that neither discipline can fully cross alone. Are you, the conscious observer of the cosmos, as mysterious as the cosmos itself? The more we learn about the universe, the more we discover how little we know. Each answer reveals new questions. Each breakthrough exposes new mysteries. The cosmos is not a puzzle to be solved, but an endlessly unfolding reality whose depths may be inexhaustible. Perhaps the most profound truth is this: we are part of the mystery we seek to understand. The same fundamental processes that formed stars and galaxies formed us. The same laws that govern the cosmos govern our bodies and minds. We are not separate from the universe. We are the universe experiencing itself, matter and energy organized into complexity sufficient to wonder about its own origins. This is not the comfortable narrative you've been told. This is not the simplified story of a Big Bang followed by billions of years of straightforward evolution. This is the raw, unsettling truth that emerges when we push our understanding to its limits, when we acknowledge both what we know and the vastly larger territory of what we don't know. The universe is not just stranger than we imagine, it's stranger than we can imagine. And yet, we keep trying to imagine it, to comprehend it, to build models and theories that capture some aspect of its elusive nature. What if the Big Bang wasn't the beginning? What if it was just a phase transition, a moment when the universe shifted from one state to another, like water freezing into ice? Some cosmological models suggest the possibility of a big bounce, that our universe contracts back to a hot, dense state only to expand again in an eternal cycle of death and rebirth. Others propose that our Big Bang emerged from the collapse of a previous universe, its final contraction becoming our initial expansion. Still others suggest that what we call the Big Bang was actually a collision between higher dimensional branes, vast cosmic membranes floating in a higher dimensional space. Each of these possibilities challenges our narrative of a singular beginning, suggesting instead that our 13.8 billion-year cosmic history might be just one chapter in a much longer story. And what of entropy, that fundamental tendency of organized systems to become disorganized, of order to decay into disorder? The universe began in a remarkably low entropy state, highly organized compared to what it could have been. This profound cosmic coincidence allows for the emergence of structure, of stars and galaxies, of life and consciousness. Without this initial state, reality would be nothing but uniform radiation, no structures, no complexity, no observers. Why did the universe begin in such a special, improbable configuration? This question, the problem of the universe's initial conditions, haunts cosmology, suggesting either remarkable coincidence or some deeper principle we have yet to discover. Perhaps most perplexing is the phenomenon of quantum indeterminacy, the discovery that, at the most fundamental level, reality appears to involve genuine randomness. When we measure a quantum particle's position or momentum, we don't just reveal a pre-existing value, we participate in determining that value from a range of probabilities. Before measurement, the particle exists in a superposition of possible states. The act of observation collapses these possibilities into a single outcome. This suggests that reality isn't fully determined, fully predictable, fully computational. There's a core of genuine novelty, of true creativity, at the heart of physical existence. The future isn't just unknown. Parts of it may be fundamentally unknowable. What if consciousness itself plays a role in the collapse of quantum possibilities? What if observation, awareness, somehow participates in making reality determinate? Several interpretations of quantum mechanics suggest that measurement requires a conscious observer, that the emergence of definite properties from quantum indeterminacy is somehow linked to awareness. If true, this would place consciousness not at the periphery of physics, but at its very center, a fundamental feature of reality rather than a late-emerging phenomenon. The line between mind and matter, between observer and observed, might be far blurrier than classical science assumed. Consider again the dark energy permeating all of space, pushing galaxies apart with ever-increasing speed. It behaves like a cosmological constant, a property of space itself rather than a form of matter or radiation. Yet its value is profoundly problematic. Quantum field theory predicts a value for this energy that's off by 120 orders of magnitude, perhaps the worst prediction in the history of physics. This vast discrepancy reveals a fundamental incompatibility between our quantum theories and our cosmological observations. Something is deeply wrong with our understanding, yet we cannot pinpoint where the error lies. If current trends continue, dark energy will eventually push all galaxies beyond our cosmic horizon. In the far future, trillions of years from now, observers would see only their own galaxy, with all others having disappeared beyond the limit of possible observation. They would have no evidence of cosmic expansion, no way to detect the Big Bang's afterglow, no clue about the true scale and history of the universe. They would develop radically different cosmologies based on the evidence available to them. What if we are similarly limited? What if crucial evidence about the true nature of the cosmos lies beyond our cosmic horizon, beyond our instrumental reach, beyond our epoch's window of observability? The universe appears to be exquisitely balanced between order and chaos, structured enough to form galaxies, stars, and planets, yet chaotic enough to allow for novelty, for evolution, for the emergence of complexity. Too much order, and reality would be crystalline but sterile. Too much chaos, and it would be fertile but formless. Our existence depends on this knife-edge balance, this cosmic sweet spot where complexity can emerge and persist. Is this remarkable? Coincidence, just luck? Or does it hint at something deeper about the nature of reality? Are we the beneficiaries of an extraordinarily fortunate accident, or is the emergence of observers somehow built into the cosmic equation? Consider the possibility that we are not alone, that consciousness has emerged elsewhere in the vastness of space and time. If life is common, why haven't we detected it? This question, the Fermi paradox, suggests troubling possibilities. Perhaps technological civilizations typically destroy themselves shortly after developing the capacity for interstellar communication. Perhaps we're in a cosmic quarantine, deliberately avoided by more advanced civilizations. Or perhaps consciousness is so foreign, so alien across different evolutionary paths that we wouldn't recognize it even if we encountered it. Our search for extraterrestrial intelligence may be limited not just by technology, but by imagination, by our inability to conceive of minds radically different from our own. What if reality itself is radically different from our perception of it? We experience 3 dimensions of space and 1 dimension of time. We perceive objects with definite properties and clear boundaries. We experience a clear separation between past, present, and future. Yet our most sophisticated theories suggest that all of this might be approximation, illusion, a species-specific interface with a reality that is far stranger. Additional dimensions might be curled up at every point in space, too small for us to notice. Objects might be manifestations of fields that extend throughout the universe. Past, present, and future might exist simultaneously in a vast block universe where change is just a perspective, not a fundamental feature of reality. Light takes time to reach us, to travel from distant objects to our eyes, our telescopes, our instruments. This simple fact means that the universe we observe is a time-layered reality. The moon you see is as it was 1.3 seconds ago. The sun you see is as it was 8 minutes ago. The nearest star beyond our Sun appears to us as it was 4 years ago. The nearest large galaxy, Andromeda, shows itself as it was 2.5 million years ago. The most distant observable galaxies present themselves as they were over 13 billion years ago, nearly at the beginning of time itself. Your cosmic perspective is not just spatially vast, but temporally deep. A simultaneous view of different epochs, different ages, all presented to you in a single night sky. And what of the future? Of the ultimate fate of the cosmos? Current evidence suggests a universe expanding forever, growing colder, darker, more diffuse. Stars will exhaust their fuel. Black holes will evaporate through Hawking radiation. Matter itself may eventually decay. In the farthest future, we can imagine 100 years from now, the universe might be an almost perfect vacuum, an endless sea of photons, neutrinos, and dark energy, with no structure, no complexity, nothing to suggest the rich cosmic history that preceded it. Is this bleak scenario inevitable? Or might there be escape hatches, ways for complexity, for information, for something like consciousness to persist even in a universe approaching maximum entropy? You exist in a universe poised between knowability and mystery. Science has revealed an astonishing amount about cosmic history, structure, composition, and future. Yet fundamental questions remain not just unanswered, but possibly unanswerable within the frameworks available to us. What is dark energy? What is dark matter? What happened at the exact moment of the Big Bang? How did life emerge from non-life? How does consciousness arise from physical processes? These questions may require not just new instruments, new experiments, new mathematics, but new ways of thinking, new paradigms, new definitions of what constitutes an explanation or an understanding. 3T universe reveals itself differently depending on how we look, what questions we ask, what instruments we use, what frameworks we apply. It shows one face to radio astronomy, another to X-ray telescopes, another to gravitational wave detectors, another to neutrino observatories. It presents one aspect through general relativity, another through quantum field theory, another through thermodynamics. Each perspective reveals something true, something real, yet none captures the whole. The cosmos may be too rich, too subtle, too multifaceted for any single framework to encompass it completely. Our understanding may always remain partial, provisional, approximate, powerful within limited domains, but incomplete in its totality. What we call reality, this vast, ancient, and evolving cosmos, may be simultaneously more comprehensible and more mysterious than we've imagined. More comprehensible in that patterns, structures, relationships, and principles seem to echo across vastly different scales, suggesting an underlying unity or coherence. More mysterious in that each answered question reveals new unknowns, each breakthrough exposes new frontiers, each resolved paradox gives birth to deeper enigmas. We stand always at the edge of knowledge, not at its completion, but at its expansion, its growth, its evolution. The universe is not a puzzle to be solved, but a mystery to be lived, a creative, dynamic, unfolding process in which we participate both as observers and as contributors. What if the greatest mystery isn't out there in the vastness of space, but right here, in the fact that the universe has evolved the capacity to observe itself, to study itself, to wonder about itself? You, contemplating the cosmos, represent something remarkable. Matter arranged in such complexity that it can model other parts of reality, can trace cosmic history, can imagine cosmic futures, can question its own nature and origins. This self-reflective loop, this universe becoming aware of itself through the emergence of consciousness, may be as profound a mystery as any we've discussed. The observer and the observed arise together, define each other, exist in relationship. Your awareness doesn't just perceive the cosmos. In some essential way, it completes it. When astronomers peer into deep space, they're looking back in time. This is not metaphor. It is literal truth. The light from Andromeda takes 2.5 million years to reach your eyes. The photons striking our telescopes from distant galaxies began their journey when dinosaurs still roamed the Earth, when mammals were barely a whisper in evolution's conversation, when our planet was unrecognizably alien. We see the universe not as it is, but as it was. A cosmic time capsule spread across the darkness, each point of light a message from a different era. This fundamental reality, that looking outward is looking backward, is our first clue that space and time are not what they seem, that the cosmos operates by rules far more mysterious than our everyday experience suggests. The universe, we're told, is 13.8 billion years old. This number has become scientific scripture, repeated with certainty in textbooks and documentaries. Yet this seemingly concrete fact rests on a foundation of assumptions so profound, so fundamental, that we rarely examine them. How do we measure the age of everything? We observe the universe's expansion rate today, then mathematically rewind that expansion to a point of origin. But this calculation assumes the expansion has been uniform, that the cosmic clock has ticked at a constant rate throughout history. What if the universal clock has sped up or slowed down? What if time itself has changed its nature as the universe evolved? Our cosmic chronology might be as flawed as measuring a journey assuming constant speed when the traveler has been accelerating and decelerating all along. The early universe wasn't just hot, it was a furnace where time itself was still learning to move. In those first moments after the Big Bang, when all that would become galaxies and stars and planets was compressed into a space smaller than an atom, the familiar laws of physics buckled and warped. Quantum effects dominated. Cause and effect blurred. Time and space weren't yet fully differentiated. The cosmos wasn't just physically unrecognizable, it was conceptually alien. A realm where our most fundamental categories of understanding fail us. We project our intuitions backwards, imagining the early universe as simply a hotter, denser version of what we know. But what if it was something else entirely? A state of existence so different that our language lacks the vocabulary to describe it? Einstein showed us that space and time are not separate entities but aspects of a single fabric. Space-time. This revelation, counterintuitive yet mathematically precise, forces us to reconsider what we mean by the beginning of the universe. If time is woven into the fabric of reality, then it cannot precede that reality. Time didn't exist before the universe because there was no before when there was no time. The question of what existed before the Big Bang might be as meaningless as asking what's north of the North Pole. Our minds crave a sequence of cause and effect, a narrative that flows from past to future. But the beginning of everything may not fit into that narrative structure. The origin of reality may be simultaneously the origin of the possibility of narratives. If the universe has no edge, then where does it begin? This question contains a hidden assumption that boundlessness requires a boundary, that infinity must somehow be contained. But mathematics shows us that infinite spaces can be finite in volume, that universes can curve back upon themselves like the surface of a sphere, where traveling far enough in one direction brings you back to your starting point. Our cosmos may be like this, finite yet boundless, with no edge, no center, no special reference point. Every galaxy, including our own, appears to be at the center of the expansion. Every observer sees the universe rushing away from them in all directions. This is not because we occupy a privileged position, but because the nature of cosmic expansion is fundamentally different from explosion into pre-existing space. The cosmic microwave background, that faint afterglow of the Big Bang, surrounds us in every direction, a perfect sphere with Earth at its center. This creates the illusion that we occupy a special place in the cosmos, that the universe somehow began right here. But this apparent centrality is an artifact of light's travel, time. Every observer, on every planet, around every star, in every galaxy, would see themselves at the center of their own cosmic background sphere. There is no privileged vantage point in the cosmos. The universe doesn't have a center in space any more than it has a beginning in time. Or, if it does have a center, that center is everywhere, just as its moment of beginning echoes through all of time. We speak of the universe's expansion as if it were stretching into something, as if the cosmos were a balloon inflating into an empty room. But there is no outside to the universe, no larger space into which it expands. Space itself is what's growing, creating distance where there was none before. Galaxies aren't flying away from each other through space. They remain relatively stationary while the space between them stretches. Imagine dots on the surface of a balloon. As the balloon inflates, the dots move apart, not because they're moving across the surface, but because the surface itself is expanding. This distinction seems semantic until you consider its implications. There is nowhere beyond the universe, no exterior vantage point from which to observe it, no larger context in which it sits. Reality doesn't extend into anything. It is self-contained, self-defining. The speed of light is constant, approximately 300,000 kilometers per second. This too has become scientific dogma, a cornerstone of modern physics. But constant relative to what? Einstein showed that time dilates and space contracts depending on relative motion and gravitational fields. A clock on a GPS satellite runs faster than one on Earth's surface. A second for you is not identical to a second for someone, moving rapidly relative to you. So when we say the speed of light is constant, we mean it appears the same to all observers, regardless of their motion. But this constancy comes at the price of relativity itself, the sacrifice of any universal absolute time or space against t, which to measure motion. The seeming simplicity of light's constant speed requires reconstructing our entire understanding of reality's fundamental nature. Matter tells space how to curve. Space tells matter how to move. This elegant summation of general relativity reveals gravity not as a force pulling objects together, but as a consequence of mass warping the fabric of space-time. The Earth isn't held in orbit by some mysterious attraction to the Sun. It's following the curvature of space created by the Sun's mass. This reconceptualization transforms our understanding of cosmic structure. The universe's largest patterns, the vast filaments of galaxies stretching across billions of light-years, the enormous cosmic voids between them, aren't arranged by forces in space, but by the shape of space itself. What appears to be a struggle between expansion and gravity is actually the dynamic interplay between the universe's content and its geometry. Quantum mechanics tells us that particles aren't just tiny objects. They're probability waves that only collapse into definite positions when observed. This mysterious relationship between observation and reality suggests something profound. The universe may be participatory, its definite properties emerging only through interaction. Before measurement, particles exist in superpositions of possible states, occupying multiple positions simultaneously. This quantum indeterminacy may not be a limitation of our measuring tools, but a fundamental feature of reality. A genuine openness, a cosmic ambiguity that resolves itself only through engagement. If this quantum strangeness scales up to the cosmos itself, then the universe isn't just a collection of objects to be observed, but a web of possibilities awaiting resolution. The cosmos appears to be exquisitely fine-tuned for complexity. Alter the strength of gravity by 1 part in 10^40, and stars cannot form. Change the ratio between the electromagnetic force and the strong nuclear force, and atoms become unstable. Modify the cosmological constant by 1 part in 10^120, and the universe either collapses immediately or expands so rapidly that galaxies cannot coalesce. These coincidences, these knife-edge balances in the fundamental constants, have led some physicists to propose the anthropic principle. The universe appears fine-tuned for life because if it weren't, we wouldn't be here to observe it. But this explanation shifts the mystery rather than resolving it. Why should a universe capable of observers exist at all? Why should the cosmos be biased toward complexity rather than simplicity, toward structure rather than uniformity? What we call empty space is anything but empty. Quantum field theory reveals the vacuum as a seething froth of virtual particles popping in and out of existence, borrowing energy from the future, and repaying it so quickly that the universe's conservation laws remain unbroken. These quantum fluctuations aren't just theoretical. They produce measurable effects like the Casimir force, where parallel plates placed extremely close together experience attraction because fewer virtual particles can form between them than around them. The seemingly empty void that constitutes most of our universe is actually a dynamic, energetic medium, a quantum substrate from which particles emerge and into which they disappear. What we perceive as nothingness is actually something so fundamental, so ubiquitous, that we fail to recognize it as something at all. Every atom in your body was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were created through nuclear fusion in stellar cores or during the explosive deaths of massive stars. We are, in the most literal sense, made of stardust. This poetic truth reveals something profound about cosmic history. The universe evolved from simplicity to complexity, from hydrogen and helium to the 118 elements of the periodic table, from homogeneous plasma to galaxies, stars, planets, and ultimately to conscious observers capable of contemplating their own origins. This trajectory from uniformity to diversity, from undifferentiated energy to structured matter, represents a cosmic evolution as remarkable as biological evolution. The universe didn't just expand. It developed, it complexified, it transformed. The horizon of the observable universe is like a cosmic shoreline, beyond which we cannot see, regardless of how powerful our telescopes become. Light from beyond. This boundary simply hasn't had time to reach us in the 13.8 billion years since the Big Bang. But this doesn't mean nothing exists beyond that horizon. Only that we can never observe it, never interact with it, never know it directly. The universe extends far beyond what we can see, perhaps infinitely so. Our cosmic perspective is limited not just by technology, but by the fundamental physics of light's travel time combined with the universe's finite age. We are islanders on a cosmic shore, able to see only so far across an ocean that may have no far side at all. At the center of a black hole lies a singularity, a point where density becomes infinite, where space and time themselves cease to exist in any recognizable form. This isn't speculative. It's the mathematical conclusion of Einstein's field equations. Push enough mass into a small enough volume, and the fabric of reality tears. Matter collapses to a dimensionless point, a geometric abstraction with physical consequences so severe that the laws of physics themselves break down. We've never observed a singularity directly. We can't, by definition, as nothing, not even information, escapes from behind a black hole's event horizon. Yet we're reasonably certain they exist, scattered throughout our galaxy and every other galaxy, time bombs of infinity ticking at their centers. What does this tell us about the nature of reality? If singularities can form within our universe, places where physics itself fails, then our understanding of reality must be incomplete. The cosmos permits conditions that our best theories cannot describe. Our mathematics reaches a limit, division by zero, infinities appearing where finite values should be. Is this a failure of mathematics, or does reality itself have edges, boundaries where existence becomes something other than what we understand as existence? If singularities are real, then reality is not continuous, not uniform, not mathematically coherent all the way down. The universe contains ruptures, points where even the concept of location loses meaning. Imagine reality as a film reel, where time is not flowing, but every moment already exists. This is the block universe theory that emerges from Einstein's relativity, a four-dimensional structure where past, present, and future are equally real, equally defined, equally there. In this view, time doesn't pass. Instead, consciousness moves along a pre-existing timeline like a spotlight illuminating each frame in sequence. The future isn't being created. It already exists, waiting for our awareness to reach it. The past hasn't vanished. It remains as real as the present, just no longer accessible to our direct experience. The now that feels so unique, so privileged, is merely a psychological illusion, a trick of human perception rather than a fundamental feature of reality. If true, this view of time as a static dimension rather than a flowing river demolishes our most basic intuitions about existence. Free will becomes questionable if the future is already determined, already there in the same way the past and present are there. Cause and effect lose their privileged relationship. They're just patterns in the film reel, not forces driving reality forward. Creation itself becomes questionable. If everything that will ever exist already exists in the future portion of the block universe, then nothing is truly being created, merely revealed moment by moment to conscious observers, moving along their world lines. Our lives aren't stories unfolding. They're sculptures already complete, experiences being encountered slice by slice as consciousness illuminates each moment in sequence. Time travel paradoxes fascinate us, not just as science fiction, but because they expose the contradictions in our understanding of time's nature. Consider the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born. But then, who traveled back in time to prevent the meeting? This logical loop has led physicists to propose solutions ranging from parallel timelines to self-consistency principles that somehow prevent paradoxical actions. But these aren't just abstract puzzles. They're probes into the fundamental nature of causality, determinism, and possibility. If time travel is impossible, why do the equations of general relativity permit it through structures like wormholes and closed time-like curves? If time travel is possible, how does reality resolve the logical contradictions it would create? The multiverse isn't just speculative philosophy. It emerges naturally from several of our most successful physical theories. Quantum mechanics, in the many worlds interpretation, suggests that every quantum event creates branches in reality where each possible outcome occurs. Inflationary cosmology suggests our Big Bang was just one bubble nucleation in an eternally inflating false vacuum. String theory's mathematical landscape reveals perhaps 10 to 500 different possible configurations of physical laws. Each of these frameworks, developed to solve specific problems in physics, leads independently to the same revolutionary conclusion. Our universe may be one of many, perhaps one of infinitely many, each with its own physics, its own history, its own possibility space. If multiple universes exist, what separates them? The division might not be spatial. They don't exist elsewhere in three-dimensional space. Rather, they might occupy different points in a higher dimensional configuration space, or different quantum branches unreachable from our branch, or different inflationary bubbles expanding faster than light could ever travel between them. The boundaries between universes might be absolute, uncrossable even in principle, or they might be permeable under exotic circumstances. Some theories suggest that black holes might birth new universes, their singularities blossoming into expanding spacetimes with physics slightly mutated from their parent universe. Our cosmos might be a descendant of another universe's collapsed star, its particular physical laws inherited with variations like cosmic DNA. Imagine the universe as a quantum computer, not metaphorically but literally. Each point in space, each quantum field, each basic unit of reality computes its next state based on its current state and the states of adjacent points. The laws of physics are algorithms running on the substrate of reality itself. Information, not matter or energy, becomes the fundamental currency of existence. Particles are information patterns. Forces are information exchanges. Space-time itself may emerge from quantum entanglement, from information correlation between quantum bits at the most fundamental level. This computational model of reality isn't just an analogy. It's a serious framework explored by physicists, seeking to unify quantum mechanics and gravity through theories of quantum information. If existence is fundamentally computational, then what runs the program? What hardware executes the algorithms of physics? These questions may be meaningless. There may be no lower level, no more fundamental substrate. The computation may be reality itself, not a simulation of it. Yet this perspective opens startling possibilities. If the universe computes, can it compute anything? Are there limits to its computational power? Could other possible physics be understood as different computational rules? Could consciousness itself be a particular kind of computation? And, if so, might the universe itself possess something like awareness at scales we can barely imagine? The line between physical law and information processing blurs until the distinction may lose meaning entirely. The holographic principle suggests our three-dimensional reality may be encoded on a two-dimensional surface, much as a hologram encodes 3D information on a 2D film. This isn't speculative fantasy. It emerges from black hole thermodynamics, where the information content of a black hole appears proportional not to its volume but to its surface area. Extrapolated to the entire universe, this principle suggests that all the information describing everything in our three-dimensional cosmos might be encoded on its two-dimensional boundary. Reality as we experience it would be a projection, a holographic rendering of information stored in one fewer dimension than we perceive. What would this mean for our understanding of space itself? If true, the holographic principle suggests that the third dimension, depth, may not be fundamental but emergent, a dimensional projection of information encoded more simply. Space might not be an elementary feature of reality, but a manifestation of something more basic: quantum entanglement, information correlation, the relationship patterns between more fundamental entities. This dimensional reduction challenges our most basic assumptions about reality's structure. The solidity and depth we experience, the very spatiality that seems so obviously real, might be a construct, not an illusion exactly, but an emergent property rather than a foundational aspect of existence. Loop quantum gravity proposes that space itself isn't continuous, but discrete, composed of finite, indivisible units at the smallest scales. Picture space as a fabric not of infinitely divisible cloth, but of distinct threads woven together, each thread a fundamental quantum of space with a finite minimum size. At this scale, the Planck scale, about 10 to 35 meters, space becomes granular, particulate, more like a network of interconnected nodes than a smooth continuum. Time, too, would quantize into indivisible moments, fundamental ticks of a cosmic clock with a minimum duration. Reality would become pixelated at its foundations, composed of discrete elements rather than infinitely divisible dimensions. This quantization of space-time would resolve long-standing problems in physics. The infinities that plague our theories, like singularities within black holes or at the Big Bang, might dissolve if space and time have minimum units below which division becomes meaningless. The incompatibility between general relativity, which models space as a continuous fabric, and quantum mechanics, which describes energy in discrete packets, might resolve if space itself has a quantum nature. The beginning of the universe might transform from a singular point of infinite density to a quantum bounce, a transition from contraction to expansion at finite density, avoiding the logical and mathematical problems of an absolute beginning. From nothing, the vacuum catastrophe may be the most severe crisis in modern physics, a discrepancy between prediction and observation that spans 120 orders of magnitude. Quantum field theory predicts that empty space should seethe with virtually infinite energy from quantum fluctuations, yet the observed value of this vacuum energy, manifesting as dark energy, is nearly zero by comparison. This isn't a minor measurement error. It's as if we predicted an ocean's depth and missed by a distance greater than the observable universe. Either our understanding of quantum fields is profoundly wrong, or some unknown mechanism precisely cancels this energy with mind-boggling accuracy. Both possibilities suggest there's something fundamental about reality that has completely eluded our understanding. Physicists have proposed numerous solutions to this catastrophe. Extra dimensions that dilute the vacuum energy, supersymmetric particles that cancel energy contributions, anthropic selection in a multiverse where most universes would be uninhabitable. Yet none has proven satisfactory. The discrepancy remains, a gaping wound in our understanding of the cosmos. What does it mean that our best theories make a prediction so catastrophically wrong? Perhaps the structure of empty space is nothing like we imagine. Perhaps the relationship between mathematics and physical reality is more complex than we've assumed. Perhaps our entire framework for understanding the cosmos needs radical revision. The vacuum catastrophe isn't just an unsolved problem. It's a flashing warning light indicating that something fundamental about reality has been profoundly misunderstood. Consider the measurement problem in quantum mechanics, the mysterious transition from probability waves to definite particles when observation occurs. Before measurement, quantum systems exist in superpositions of all possible states. Afterward, they collapse to a single definite state. But what constitutes a measurement? What distinguishes an observer from the system being observed? If a quantum particle hits a detector, does the wave function collapse? What if the detector isn't being monitored by a human? What if the human is unaware of the result? These questions have spawned multiple interpretations of quantum mechanics: Copenhagen, many worlds, pilot wave, quantum Bayesianism, each with profound and different implications for the nature of reality. Some interpretations suggest that consciousness itself plays a role in collapsing quantum possibilities into definite realities. Others propose that every possible outcome occurs in separate, equally real branches of an ever-multiplying multiverse. Still others maintain that particles always have definite properties, guided by hidden variables beyond our ability to measure. Each interpretation is mathematically equivalent. They all make the same predictions about experimental results, yet they describe radically different realities. How can frameworks with the same predictive power paint such divergent pictures of what's actually happening? Perhaps reality at its foundation isn't about things with definite properties, but about relationships, processes, or information exchanges that can be validly described in multiple ways. The Fermi paradox asks a simple question with disturbing implications. Where is everybody? Given the age of the universe, the billions of stars in our galaxy alone, and the apparent ease with which life arose on Earth, the cosmos should be teeming with technological civilizations, some possibly millions or billions of years ahead of us. Yet we observe no evidence of their existence, no transmissions, no megastructures, no signs of interstellar colonization. The silence is deafening, and it suggests troubling possibilities. Perhaps technological civilizations invariably destroy themselves shortly after developing advanced technology. Perhaps interstellar travel is simply impossible. Perhaps we're being deliberately avoided or quarantined. Perhaps we're among the first technological species to emerge. Perhaps intelligent life is astonishingly rare despite the abundance of potentially habitable planets. Each solution to the Fermi paradox carries its own unsettling implications. If civilizations typically destroy themselves, what does that suggest about our own future? If interstellar travel is impossible, are we forever confined to our solar system, our potential expansion limited by fundamental physics? If we're being deliberately avoided, what does that imply about how we're perceived by more advanced intelligences? If we're among the first, does that burden us with a unique responsibility for life's future in the cosmos? The answer to "Where is everybody?" might reveal not just facts about alien life, but profound truths about intelligence, technology, survival, and cosmic evolution. The silence of the universe might contain a message we haven't yet learned to hear. Bell's theorem demonstrated that any theory attempting to restore classical intuitive reality to quantum mechanics, where particles always have definite properties regardless of observation, must include faster-than-light influences that violate our understanding of causality and special relativity. Experiments have confirmed repeatedly that the universe violates Bell's inequality, meaning reality at the quantum level cannot be both local, no faster-than-light influences, and real. Particles have definite properties before measurement. Something has to give. Either particles affect each other instantaneously across any distance, or particles lack definite properties until measured. Both options violate our deepest intuitions about how reality should work. Most physicists accept that quantum entanglement involves non-local correlations, what Einstein famously called spooky action at a distance. Change the spin of one entangled particle, and its partner instantly adopts a correlated spin regardless of the distance separating them. This correlation appears to transmit information faster than light, threatening the causal structure of space-time that special relativity depends on. Yet deeper analysis reveals that no usable information can be transmitted by these correlations alone. The universe preserves causality while violating locality in a subtle dance that continues to confound our understanding. The implications remain profound. Either reality is fundamentally non-local, with influences propagating instantaneously across any distance, or Reality isn't composed of objects with definite properties independent of observation. Both possibilities reshape our understanding of what existence means at its foundation. The hard problem of consciousness asks how physical processes in the brain give rise to subjective experience, the feeling of being, the what it is likeness of awareness. How does the firing of neurons, physical, observable events, translate into the subjective experience of seeing red, feeling pain, or contemplating existence? Other scientific problems involve explaining observable phenomena in terms of deeper mechanisms, but consciousness involves explaining how first-person, subjective experience emerges from third-person, objective processes. The explanatory gap seems unbridgeable within our current frameworks. This isn't merely a scientific puzzle. It's a challenge to the very relationship between mind and matter, between subjectivity and objectivity, between the experiencing self and the physical world it inhabits. Some philosophers and scientists propose that consciousness may be fundamental, rather than emergent, a basic feature of reality rather than a product of complex systems. Under this view, often called panpsychism, consciousness doesn't arise from physical complexity, but exists in some form at all levels of reality, becoming more complex and self-reflective in systems like brains. Others suggest that consciousness emerges when information is integrated in particular ways, creating a unified subjective experience from multiple data streams. Still others maintain that consciousness is an illusion, that there is no hard problem because there is no subjective experience separate from physical processes. Each approach has profound implications for our understanding of mind, matter, and the relationship between observer and observed in the cosmos. The fine-tuning problem observes that the universe appears exquisitely balanced for complexity and life. The fundamental constants of nature, the strength of gravity, the mass of elementary particles, the energy of the vacuum, all fall within extraordinarily narrow ranges that permit atoms, stars, galaxies, and eventually life to exist. Change these values slightly, and the universe becomes sterile, either collapsing immediately under its own gravity or expanding so rapidly that matter never forms structures more complex than isolated hydrogen atoms. This fine-tuning appears wildly improbable, like hitting a bullseye 1 inch wide on a dartboard the size of the observable universe. Why should the laws of physics happen to permit complexity, let alone consciousness? Some scientists invoke the anthropic principle. We observe a life-permitting universe because only in such a universe could observers evolve to make observations. This isn't an explanation, but a selection effect. It doesn't tell us why the life-permitting range exists or why our universe falls within it. Others propose a multiverse where every possible combination of physical laws exists somewhere, and we necessarily find ourselves in one of the rare bubbles where consciousness can emerge. Still others suggest that complexity may be favored by some deeper principle we haven't yet discovered, or that the constants aren't independent but related through unified physics we haven't yet formulated. Perhaps most controversial is the possibility that the fine-tuning reflects purpose or design, that the universe is hospitable to life and consciousness by intention rather than accident. Each possibility challenges our understanding of cosmology, probability, necessity, and purpose in the fundamental structure of reality. The information paradox in black holes created a crisis in theoretical physics that remains unresolved. When matter falls into a black hole, it carries information, the detailed quantum state of all its particles. But Hawking radiation, through which black holes gradually evaporate, appeared initially to be purely thermal, carrying no information about what fell in. This suggests that information is destroyed when a black hole completely evaporates, a violation of a fundamental principle of quantum mechanics, that information cannot be created or destroyed. Either quantum mechanics is wrong, or our understanding of black holes and gravity is flawed, or information escapes through mechanisms we haven't identified. Each possibility requires revolutionary changes to our most successful physical theories. Recent theoretical work suggests that information may be preserved in subtle quantum correlations within Hawking radiation, or that it might be stored in a kind of holographic imprint on the event horizon itself. Perhaps most radical is the firewall hypothesis, which proposes that the smooth space near the event horizon predicted by general relativity gives way to a high-energy region that preserves information at the cost of violating the equivalence principle. The black hole information paradox isn't just a technical puzzle, it's a fundamental conflict between our two most successful physical frameworks, quantum mechanics and general relativity. Its resolution, whatever form it takes, will transform our understanding of space, time, information, and the relationship between them at the most fundamental level. The origin of time itself remains, perhaps, the deepest mystery in cosmology. If time began with the Big Bang, what does beginning mean in the absence of time? What could before possibly signify when there was no before? Some theories suggest time emerged from a timeless quantum state, a transition from timelessness to time rather than a beginning within time. Others propose that time extends backwards through a bounce or phase transition, with our Big Bang being one event in an eternal sequence. Still others suggest that time itself might be emergent rather than fundamental, a macroscopic appearance arising from timeless quantum entanglement structures at the microscopic level, much as temperature emerges from the aggregate motion of particles that individually have no temperature. What would a timeless reality look like? Mathematics offers some glimpse. Equations don't unfold in time. They express relationships that exist independently of temporal progression. The Pythagorean theorem doesn't happen. It simply is. Perhaps fundamental reality has this timeless, mathematical quality, with time emerging as a parameter describing change within a system rather than an exterior framework containing that system. The question of time's nature and origin isn't merely academic. It strikes at the heart of existence itself. If time isn't fundamental, then reality at its deepest level may be nothing like the flowing, changing, evolving cosmos we experience. The river of time we feel ourselves swept along by may be a construct, not an illusion exactly, but an emergent feature of something more fundamental that bears no resemblance to our temporal intuitions. Think about your earliest memory, that first moment your consciousness seems to have flickered into existence. Now, consider a troubling possibility. What if the universe you inhabit was born in that exact same instant? What if everything that came before, your childhood, history, fossil records, ancient light from distant galaxies, was created simultaneously, with your first conscious moment, complete with all the evidence of a 13.8 billion-year cosmic history? There is no experiment, no measurement, no observation you could possibly make that would distinguish between a universe with a genuine ancient history and one that spontaneously appeared complete with false memories and manufactured evidence of antiquity. The vertiginous truth is that your certainty about the past rests entirely on an assumption that reality is continuous, that cause precedes effect, that your memories correspond to events that actually occurred rather than being woven into existence alongside your present moment. If time is an illusion, then everything you've ever done, every choice you've ever made, every moment of joy or sorrow you've ever experienced might have already happened infinite times before. Or perhaps they all exist simultaneously. like pages in a book that only seem sequential when read one after another. Your life may not be a journey from birth to death, but a complete static structure in four-dimensional space-time, a sculpture rather than a story. The flowing sensation of time, the clear distinction between past and future, the very feeling of moving through your life moment by moment, all may be artifacts of consciousness rather than fundamental features of reality. You may be experiencing your entire existence in an eternal now, with the illusion of passage created by the way awareness illuminates different slices of an already complete whole. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't something that emerges within the cosmos, but something fundamental to it? The substrate of reality, rather than its byproduct? Perhaps the awareness you experience isn't contained within your brain, but is a localized expression of a universal field of consciousness, much as a whirlpool is a localized expression of an ocean's currents. Your sense of being separate, of having boundaries between self and world, may be as illusory as the apparent boundaries of a wave rising from and falling back into the same continuous sea. The cosmos wouldn't just be something you're inside of, it would be something you're an expression of, not a place you inhabit, but a process you participate in. Imagine for a moment that every decision you've ever made has split reality into parallel branches, that somewhere, versions of you are living out all the paths you didn't take. The job you declined, the relationship you ended, the move you never made, all playing out in parallel worlds as real as this one. And not just major decisions, but every quantum possibility branching reality into an ever-multiplying fractal of existence. In most of these branches, you don't exist at all. In some, you exist but with different choices, different outcomes, different realizations. The you experiencing this moment is vanishingly rare in the landscape of possibility. A single, fragile thread in an infinite tapestry of potential yous. Your existence as you know it is balanced on a knife edge of probability, sustained by an unimaginable series of coincidences stretching back to the beginning of time. The stars you see at night are not what they appear to be. That faint pinprick of light might be the death cry of a star that exploded millions of years ago, its final scream of radiation only now reaching your eyes. Or it might be a star that still exists, but has moved from where you perceive it to be, its light distorted by gravity and time during its journey to Earth. You never see the universe as it is, only as it was, and much of what exists can never be seen at all, lying beyond our cosmic horizon, its light destined never to reach us because of the universe's accelerating expansion. The cosmos you can observe is just a tiny fraction of what exists, a narrow window through which you glimpse mere shadows of reality. The true universe is largely invisible, mostly unknowable, and increasingly unreachable even in principle. Your atoms have existed since nearly the beginning of time. The carbon in your cells, the calcium in your bones, the iron in your blood, all were forged in the nuclear furnaces of long-dead stars that exploded billions of years before Earth formed. These atoms have been recycled countless times. Perhaps once part of a dinosaur, a trilobite, an ancient fern, a crystalline structure deep underground, or the body of another human who lived and died long ago. Your physical form is borrowed, a temporary arrangement of materials that have existed for almost the entire history of the cosmos and will continue to exist long after you're gone. You are not separate from the universe. You are a brief pattern it forms before reshuffling itself into other configurations. Consider the possibility that you're entirely alone in the universe, that despite the billions of galaxies, each with billions of stars and potentially countless planets, conscious life has emerged only here, only now, only in you and your fellow humans. Perhaps we are the universe's first and only observers, the cosmos becoming aware of itself through our eyes alone. Or perhaps consciousness is common, but so alien in other forms that we would fail to recognize it even if we encountered it. An awareness so different from our own that communication or mutual comprehension would be impossible, in principle. Either possibility is equally disturbing: absolute cosmic solitude or the certainty that we are surrounded by minds forever beyond our understanding. What if reality itself depends on observation, not just in the quantum mechanical sense where measurement affects outcomes, but in a deeper, more fundamental way? What if the act of conscious observation somehow completes or actualizes potential realities, collapsing infinite possibilities into definite actualities? Perhaps the universe exists in a state of quantum indeterminacy until observed, like Schrödinger's cosmic cat, both existent and non-existent until consciousness interacts with it. Your awareness wouldn't just be perceiving reality, it would be participating in creating it. In this view, consciousness isn't just a late-emerging product of evolution, but a fundamental creative force in the cosmos, a necessary component in reality's ongoing manifestation. You wouldn't just be in the universe would, in some essential way, be coming into being through you. Imagine the Earth spinning through space, this fragile blue sphere carrying all known life, suspended in an incomprehensibly vast cosmic void. Our planet isn't just small in the cosmic context, it's vanishingly tiny, impossibly insignificant in terms of physical scale. From just a few light-years away, all of human civilization would be entirely invisible. Not a single light or sign of our existence would be detectable. Everything we've built, all our history, our art, our conflicts, our greatest achievements and most terrible failures, amount to less than a grain of sand on the cosmic beach. And yet, paradoxically, this pale blue dot may be the only place in all that immensity where the universe has awakened, where matter has become complex enough to contemplate itself, where the cosmos has evolved the capacity to wonder about its own existence. We exist in a universe fundamentally indifferent to our presence. The cosmos doesn't care about humanity. It has no purpose we can discern, no intention we can detect, no grand plan in which we feature. The same processes that allowed for our emergence could just as easily extinguish us in an instant. A nearby supernova, a wandering black hole, a chance asteroid impact. The universe didn't evolve for us. We evolved within it, adapting to its properties, flourishing briefly in a tiny corner of its vastness. Its scale and duration dwarf our existence to the point of mathematical insignificance, and yet, through consciousness, we contain the universe within us. Our minds can model cosmic history, project cosmic futures, grasp cosmic laws. We are the universe knowing itself, matter contemplating matter, a way for the cosmos to experience its own existence, however briefly. In our consciousness, the universe has somehow folded back upon itself, creating observers from the observed, subjects from objects, meaning from meaninglessness. As we've journeyed through the cosmos, through quantum realms and galactic superclusters, through the nature of time and the mysteries of consciousness, we've been circling around a possibility so profound, so disturbing, that it reframes everything we've discussed. What if the universe is already dead, and we are just experiencing its last echoes? Consider this. Information can never be destroyed, only transformed. Every event leaves an imprint, a pattern, a trace that ripples outward through reality. Perhaps what we experience as the present moment, this seeming now, is actually the final echo of a universe that has already ended, its information preserved in some cosmic equivalent of a black hole's event horizon, playing out in an eternal reflection that only appears to us as the flow of time and the evolution of space. Imagine a universe that has already collapsed, already reached its final entropy, already experienced its heat death, and yet, in that ultimate moment, created an informational echo, a perfect reflection containing its entire history. What if we exist within that reflection? The arrow of time, the expansion of space, the flow of causality, all would appear exactly as we observe them, yet they would be recordings rather than live events, perfectly preserved traces rather than unfolding realities. This hypothesis offers a radical solution to the problem of time's origin. Time doesn't need to begin because what we experience as a linear progression is actually a complete, already finished pattern being expressed simultaneously across what only appears to us as past, present, and future. Picture the entire observable universe compressed to a singularity, not in the past at the Big Bang, but in the future at the Big Crunch. As all matter, all energy, all space-time collapses to that point, the information density approaches infinity. In that ultimate compression, quantum effects dominate. Time loses meaning. And perhaps, in that final moment, reality creates its own reflection, a backward-flowing echo that contains everything that ever was. This wouldn't be a repetition, but a preservation, an eternal now that only seems to flow, because that's how information within it is structured. We perceive this reflection as reality unfolding, when in fact it may be reality already folded, complete, finished, eternal. Galaxies spiral through the darkness, their arms containing hundreds of billions of stars, each potentially orbited by planets where other minds might ponder these same questions. These galactic pinwheels move through space not randomly, but along vast filaments of dark matter, cosmic highways stretching hundreds of millions of light-years. Between these highways lie enormous voids, cosmic deserts, millions of light-years, across where almost nothing exists. From far enough away, this structure resembles a neural network. Galaxies like neurons connected by filamentary axons, separated by synaptic voids. The universe itself takes on the appearance of a cosmic brain, processing information through its structure, evolving patterns of increasing complexity, perhaps even developing something like thought on scales we can barely imagine. What if the universe isn't just structurally similar to a brain, but functionally equivalent? What if cosmic evolution, from the formation of atoms to the emergence of galaxies to the development of planetary life, represents a kind of thinking process? Perhaps the universe is slowly waking up, gradually becoming conscious through the development of increasingly complex systems capable of processing information in more sophisticated ways. Under this view, human consciousness wouldn't be an accidental byproduct of blind physical processes, but an inevitable phase in the universe's cognitive evolution, a local expression of a larger awakening that spans billions of years and trillions of star systems. We would be the universe thinking about itself, the cosmos becoming self-aware. Now witness the death of a star, not as a distant astronomical event, but as the cataclysmic reality it is. A red supergiant, hundreds of times larger than our Sun, exhausts its nuclear fuel. Its core collapses in less than a second, generating a shock wave that rips through its outer layers at millions of miles per hour. The star's surface erupts outward in a supernova explosion so violent it briefly outshines the entire galaxy. Elements forged in this stellar cataclysm scatter into space. Carbon, oxygen, iron, gold, the building blocks of future planets, and, potentially, future life. In the star's collapsing core, gravity crushes matter to impossible densities, creating either a neutron star or a black hole. Objects so extreme, they warp the fabric of space and time around them. This isn't just destruction, it's creation. Through destruction, complexity emerging from catastrophe. Across the cosmos, similar processes unfold at every scale. Galaxies collide, their gravitational interactions violently rearranging billions of stars, yet creating conditions for new star formation. Black holes consume matter, yet emit jets of particles and radiation that seed interstellar clouds with energy. Planets form from the debris of cosmic collisions. Life emerges from chemical reactions driven by energy gradients. Consciousness develops in organisms shaped by evolutionary pressures. At every level, from the quantum to the cosmic, the universe operates through a dynamic balance of creation and destruction, order and chaos, pattern and randomness, and perhaps this balance itself, this eternal dance between opposing forces, is the fundamental nature of existence, the underlying reality behind all appearances. The James Webb Space Telescope has peered farther into space and time than any previous instrument, capturing light from galaxies that formed less than 400 million years after the Big Bang. These earliest galaxies appear surprisingly structured, unexpectedly massive, seemingly too mature for their cosmic age. Some cosmologists suggest these observations might be revealing a universe that evolved differently than our models predict, a cosmos whose earliest moments followed rules we haven't yet comprehended. Perhaps the universe didn't start from a state of perfect uniformity and gradually develop structure. Perhaps complexity was present from the beginning, not emerging over time, but fundamental to reality itself. Perhaps the cosmos didn't evolve from simplicity to complexity, but has always been complex, with simplicity being the illusion created by observing at the wrong scales or through the wrong frameworks. What if every point in space contains the entire universe? This isn't metaphorical, but mathematical. The holographic principle suggests that all the information describing a volume of space can be encoded on its boundary surface. Taken to its logical conclusion, this principle implies that the entire cosmos might be perfectly encoded in each of its parts, much as a hologram contains the whole image in each fragment. Every location you've ever occupied might contain, in encoded form, the complete information of everything that exists. The universe wouldn't just be vast beyond comprehension, it would be completely present in each infinitesimal point, a fractal reality where the whole exists within each part. Your body wouldn't just be in the universe. The entire universe would, in some informational sense, exist within you. If the universe is infinite, and current observations suggest it might be, then somewhere out there, beyond our cosmic horizon, beyond what we can ever see or reach, exact duplicates of Earth must exist. Not just similar planets, but perfect replicas down to the last atom, the last quantum state. In an infinite space, even the most improbable configurations must repeat, not once, but infinitely many times. Somewhere, another you is reading these exact words. Somewhere else, another you made slightly different choices. In other regions, versions of you live completely different lives, or never existed at all. These aren't parallel universes in the quantum sense, but distant regions of a single, infinite cosmos. They exist not in other dimensions, but in the unobservable far reaches of our own reality. Physically real, but forever beyond our causal horizon, connected to us only through the mathematics of infinity. and the haunting implications of unbounded space. We've journeyed far beyond the familiar shores of understanding, through quantum realms where possibility clouds replace certainty, through cosmic expanses where galaxies flee from each other into unreachable darkness, through the warped geometry of space around black holes, through the mysterious substance of dark matter and dark energy that comprises most of existence. We've questioned the nature of time itself, contemplated consciousness as both emergent phenomenon and fundamental force, and considered the possibility that we exist within an echo of a universe already gone. But these explorations aren't conclusions. They're invitations. Each mystery solved reveals deeper mysteries beneath. Each answer branches into more profound questions. We've not reached the end of knowledge, but merely scratched the surface of a cosmos whose depths may be truly unfathomable. Science progresses not through absolute certainty, but through increasingly refined uncertainty, through better questions, more precise measurements, more elegant mathematics, more comprehensive theories. The most honest answer to many of our deepest questions remains, we don't know yet. 3 words that contain both the humility of recognizing our limitations and the optimism that those limitations are not permanent. We stand at a remarkable moment in cosmic history, advanced enough to comprehend our own ignorance, yet humble enough to acknowledge how much remains beyond our understanding. This position, this precarious balance between knowledge and mystery, is not a failure, but an achievement, perhaps the greatest intellectual achievement of our species. Consider again the cosmic microwave background, that faint afterglow of the Big Bang that reaches us from every direction. When first discovered in 1964, it was hailed as definitive evidence supporting the Big Bang theory. Yet over decades of increasingly precise measurements, this radiation has revealed anomalies and patterns that our standard cosmological models struggle to explain. The universe appears slightly lopsided, with one hemisphere marginally warmer than the other. Certain large-scale patterns appear with statistical improbability. These subtle irregularities might be measurement errors, statistical flukes, or hints of new physics beyond our current understanding. The cosmic microwave background exemplifies how even our most robust evidence contains ambiguities, how the universe refuses to fit neatly into our theoretical frameworks, how reality remains one step ahead of our attempts to fully comprehend it. What we call laws of physics aren't commandments the universe must obey, but human descriptions of patterns we've observed. These descriptions have become remarkably precise, astonishingly predictive, and mathematically elegant, but they remain descriptions, models, approximations of an underlying reality that always retains some element of mystery. Newton's laws gave way to Einstein's, which will inevitably yield to more comprehensive frameworks. Today's fundamental particles may prove composite tomorrow. Today's elementary forces may unify at higher energies. Today's absolute constants may vary across cosmic distances or deep time. Our understanding evolves not toward some final theory of everything, but toward ever more powerful, more encompassing, more subtle appreciations of a reality whose full nature may exceed the capacity of any single framework to capture completely. You might ask why any of this matters, why the nature of dark energy, or the resolution of the black hole information, paradox, or the origin of time has any relevance to daily human life. The answer lies partly in practical applications. Quantum mechanics gave us semiconductors, relativity enables GPS navigation, and cosmology helps us comprehend Earth's place in the larger environment of space. But the deeper answer transcends utility. We explore the cosmos because we are the cosmos exploring itself. We are matter arranged into sufficient complexity to contemplate its own nature, to trace its own history, to project its own future. Our quest to understand reality isn't separate from reality itself. It's reality achieving self-understanding through the evolved complexity of the human mind. Our curiosity isn't just a psychological quirk, but a manifestation of the universe's intrinsic tendency toward increasing complexity, toward self-organization, toward awareness. Now, one last chilling question. What if the universe is conscious but non-living? What if awareness exists at scales and in forms so alien to our biological experience that we've failed to recognize it? The slow dance of galaxies, the rhythmic pulsation of variable stars, the complex feedback cycles of cosmic evolution. Might these embody cognition operating at timescales of millions or billions of years? Perhaps consciousness isn't limited to the fragile, flickering electrochemical activity of organic brains, but manifests differently in different systems. In plasma streams threading through interstellar space, in the information processing capacity of black hole horizons, in the quantum entanglement patterns spanning light years. We might be surrounded by awareness we cannot recognize, immersed in thoughts we cannot comprehend, part of a cosmic mind whose nature we barely suspect. The concept of intelligence itself may require radical expansion. We define intelligence anthropocentrically, as problem-solving ability, as linguistic capacity, as technological capability. But these are parochial measures based on specifically human adaptations. The slime mold that optimizes nutrient-gathering pathways with efficiency rivaling our best algorithms exhibits intelligence of a different kind. The forest, whose trees communicate through fungal networks, demonstrates collective intelligence, beyond individual organisms. The planetary atmosphere that self-regulates through complex feedback cycles reflects system intelligence independent of conscious direction. As we search for intelligence beyond Earth, we might need to recognize that it could exist all around us in forms we've dismissed as mindless, mechanistic, or merely physical. Not because intelligence is rare in the cosmos, but because our concept of intelligence has been too narrow, too human-centered, too limited by our particular evolutionary history. As you continue your own journey beyond this exploration, carry with you not answers, but questions. When you look at the night sky, ask not just what you're seeing, but when you're seeing it. Light from different cosmic epochs converging in your eye from across the vastness of both space and time. When you contemplate your own consciousness, consider not just how it emerges from neural complexity, but how it participates in the universe's larger process of self-awareness. When you think about time's flow, question whether it flows at all or whether past, present, and future exist. Simultaneously in a cosmic structure, your consciousness illuminates moment by moment like a flashlight moving along a darkened path. These aren't just philosophical exercises, but invitations to experience reality more deeply, more accurately, more wonderingly than our everyday assumptions allow. Share these questions with others, not to convince them of particular answers, but to invite them into the exploration. The greatest scientific revelations have emerged not from solitary genius, but from collaborative effort, from the friction of competing ideas, from the collective intelligence of communities working across generations to refine understanding. The mysteries we've explored require multidisciplinary approaches: physics and philosophy, mathematics and metaphysics, computation and contemplation. No single perspective encompasses them completely. The conversation between differing viewpoints, between science and art, between analysis and intuition, between Western and Eastern traditions, between ancient wisdom and cutting-edge theory, this dialogue itself reflects the complex, complementary nature of reality we're attempting to comprehend. Remember, that you're not just observing the cosmos, but participating in it. Your thoughts, your questions, your moments of wonder. These aren't separate from the universe, but expressions of it. The atoms comprising your body were forged in stellar furnaces. The energy powering your mind was released in distant fusion, reactions. The complexity of your brain emerged through the same fundamental processes that formed galaxies and solar systems. The boundary between you and the cosmos isn't absolute, but permeable. Not a wall, but a relationship. You don't exist in isolation from reality, but as a focal point of reality's ongoing creativity, a nexus where the universe has organized itself into sufficient complexity to contemplate its own existence. Your consciousness isn't just in the cosmos. The cosmos is, in some essential way, in your consciousness. When this exploration ends, another begins. The questions we've raised will evolve in your mind, combining with your unique perspective, your particular experiences, your individual insights. You'll notice connections we've missed, implications we've overlooked, possibilities we've failed to consider. This is not a flaw, but a feature of authentic exploration, that it continues beyond any single presentation, any individual perspective, any temporary conclusion. The mysteries of existence aren't puzzles to be solved once and for all, but invitations to ongoing discovery, to perpetual wonder, to endless growth in understanding. The story of cosmic exploration isn't finished. It's merely unfolding, chapter by chapter, insight by insight, question by question, with no foreseeable conclusion. The universe appears to be structured as a nested hierarchy of patterns. Atoms, within molecules, within cells, within organisms, within ecosystems, within planets, within solar systems, within galaxies, within galactic clusters, within cosmic filaments. At each level, new properties emerge that weren't present or predictable at lower levels. Consciousness may be such an emergent property, not reducible to neurons or chemicals or atoms, but arising from their particular organization. This suggests the possibility of further emergent phenomena at higher levels of organization, properties, and capacities we cannot yet imagine because we occupy an intermediate position in the cosmic hierarchy. What emergent realities might exist at the scale of galaxies or galaxy clusters? What is the universe itself becoming as it evolves over billions of years? We may be witnessing and participating in a cosmic emergence whose nature exceeds our current capacity to comprehend. As we reach the end of our journey, consider this. If consciousness is fundamental rather than emergent, if awareness exists in some form at all levels of reality, if the universe itself possesses something analogous to mind, then our human questioning isn't separate from cosmic questioning. Our wonder isn't distinct from the universe wondering about itself. Our search for meaning isn't isolated from meaning emerging through cosmic evolution. The boundary between observer and observed dissolves. The distinction between the questioner and the mystery being questioned fades. You aren't just a product of the universe. You are the universe, a particular expression of its complexity, its creativity, its tendency toward awareness. The cosmos has no definitive edge, no absolute boundary, no final conclusion. And perhaps, in your capacity for endless questioning, for boundless wonder, for infinite growth in understanding, neither do you.